Okay, so I'd like to thank you all for joining us tonight. Pint of Science is a global festival to celebrate science and to make it more accessible for people who aren't always in the science sphere. So I'm delighted to introduce Gregoire and Anastasia tonight to discuss DIY renewable energy and DIY materials. And with that, I'm going to hand over straight away to them because they're the experts with all the science and the knowledge.
Hello.
Hello. Thank you, Jackie. So
actually, we have many experts in this Zoom room because we also have Ferdi and we also have from Puebla. Like we are very nice people here. It's going to be a short presentation that merges some things about materials and some things about sustainable Fab Labs.
right. So first, we're going to have a presentation of what Fab Labs are and what is the state of the Fab Lab network today. Anastasia is also going to present some of her work that makes a direct link with the second part of this talk, which will be about off-grid Fab Lab manufacturing.
So I will directly share my screen, and yes, I hope that you can see it. I'm happy to see also, yes. So it's very interesting that when we got invited by Jackie, it was because of the project of Fabship, which is a project that we are currently leading. And it is talking about how we can make the Fab Lab world a little bit more sustainable. I will just very briefly say that FabLabs are Fabrication laboratories. It's an outreach project from MIT where it establishes a very common language between peers, between different nodes, so that we can exchange data and we can also have similar tools and processes to be able to manufacture locally and globally share. So the basic set is the machines, the small tools, the workshop, but the most important thing is this part where two brains connect with each other, and it's the sharing and open thinking. And the idea when Neil Gershenfeld established this outreach program was that he was thinking that the technologies will become as easily accessible as a simple microwave, that everyone will be able to have a 3D printer at their place. There is a lot of literature about the third industrial revolution and what is the maker movement or the hacker movement that was before doing. But very interesting to see how the Times magazine showed illustrated on the upper right part of the screen how we are going to transit to this personal computing and to manufacturing from our houses. So you can see here like a desktop and then the little factory that is coming out of our computer. And if we think about, for example, Wikipedia, we will understand that this is knowledge that is shared and is generated by the people for the people. And it is the same concept with the Fab Labs. The knowledge is open source and it is powered by the human will to share, exchange, and move forward together. So it's promoting basically, and the main ingredient of this movement is the free culture, the free software, the Creative Commons licenses. We also have like free software, but also free hardware. And this is what is a transversal spine in the digital fabrication laboratories networks that they have been replicating since now 18 years with more than 1,300 Fab Labs and thousands of users getting to meet each other and creating a vibrant community online and physically, combining this hybrid model of learning locally, but also sharing globally. And this is when we can say that we can respond to William Gibson, that is a Canadian science fiction author that introduced the term of cyberspace. And he said that the future is here, it's just not widely distributed yet. And we can tell, don't worry, Mr. Gibson. What we are doing now is that we are trying to widely distribute the future. And this is the main driver of the FabLab network. So in my work, what I have been doing since 2013 is that I established a research laboratory that is expanding the FabLab network to use and tackle topics around soft fabrication, textiles, materials, and to bring and engage with different type of stakeholders that they are coming more from artistic background or opening a little bit and making science a little bit more accessible to every type of person that is not necessarily in the engineering field. And then Fabricademy is a lab that its manifesto, it's to create and craft your materials, design your tools, and invent your processes. So we are thinking of a whole circular approach of designing and manufacturing. The focus is on 4 different topics. The first is the digital fabrication, applications of 3D printing, laser cutting, molding and casting, mainly on the textile and clothing industry, which is one very big chunk of our world, of our production system. So let's say that the Fab Textiles is kind of focusing on this aspect, on this industry. The wearable technology is how actually technology becomes an extension of our bodies and how we augment our senses through technology, through wearables, through e-textiles and soft electronics. The biomaterials, which is the topic that I would like to present today as part of the sustainability within the circular design aspects of the FabLabs, and the parametric design, which is also about sustainability, because nowadays we see that everybody wants to to be part of the process, to be part of having to customize things, to be part also of the production. So we are shifting from the model of the consumer to the model of the one that produces and consumes at the same time, which is the model of the prosumer. The Fab Textiles research since 2013 has been documented in an open source format on the webpage, where you can find different tutorials that they range from creating electroluminescent electronics to making your own ink and stamps out of pomegranate. And all of this knowledge has been, let's say, gathered, and together with other like-minded people of the network, we established an educational program that builds upon the educational programs that the FabLab network is running. And this is called the Fabricademy. And it is built upon the fashion of Fabacademy, which is the how to do almost anything. But Fabricademy is the course, it's the new course of the FabLab network that is tackling the textile and clothing industry. So give me a second. I'll stop sharing and start sharing again, because I made a mistake before. Yes.
Fabricademy is a transdisciplinary course at the intersection of textiles, digital fabrication, fashion, and biology. Participants research alternative approaches, all striving towards a more sustainable, circular, and transparent industry, guided by a group of international pioneers.
The program is unique, and it is actually what we imagine as the future discipline for fashion and textile design.
I will recommend Fabricademy if you want to be part of the future. Everything that is coming, it's here. Growing your own materials, all the biomaterials, all the sustainability.
3D printing, laser cutting, electronic, wearables.
I think there is a lot of knowledge in one course in Fabricademy. After Fabricademy, you think you can create like almost anything.
It is a 6-month, very intensive course that introduces you to 13 weeks of skills, and then you have a 2.5 months of personal project development with mentorship.
Also, the support was very important. Like, we have crazy ideas and everybody was helping us all the time.
And also, I would like to show you another very nice testimony of one of our students, that she's a professor in the School of Design and Arts in the Netherlands, in Amsterdam.
What I loved about Fabricademy is that it's a very unique place where I can bring the totally nerdy side that loves building computers, that loves building electronics, the totally crafting side where I'd like to spin my own yarn with a manual spindle, the collaborative side that requires me to work together with people to build a new machine, for example, and at the same time to imagine something very tangible, like a product, something that is functional, that you can wear, and have all these things happening at the same time in one place. It's not just one part, but it's all the tiny aspects that I enjoy doing, all combined in one place.
So in the research agenda of the program, we have 4 topics. The one is sustainability. The other one is Industry 4.0, or the digital transformation in the industry. The third one is the wearable technology. And the fourth one is the storytelling and the innovation narratives and the social entrepreneurship. When I studied architecture in Greece, they taught me that when I have to build a building or design something, I need to think about the materials that I'm going to use. I need to make some models, some maquettes, some designs, probably using some tools like AutoCAD or any CAD program that you can 3D model on the computer. Then I would prototype and see how my design would be, and then I would go look at for the providers and go into manufacturing. And this is the education that we had for the last, only in the last 20 years, these things started to change. Because unfortunately, at these moments where the Industrial Revolution was picking up and everything was for mass optimization, mass production, faster with lower price, we were not thinking at which cost. And slowly, we see that in education, and hopefully this will become the rule and not the exception, we see that the teaching methodologies and how we nowadays make the designers think about the product design or about building design is not stopping when manufacturing happens, but it is also trying to close the loop, and it is looking into what happens after the lifespan of the project, of the product. What happens after we have manufactured, after the use? So what about recycling? What about designing for disassembly? How about manufacturing? And also bringing back the materials back in the cycle. And in our case, we project this into the FabLab network, and we start asking ourselves, here we can make almost anything, but where does the material come from? If we can make almost anything, why don't we start also making our own materials? Then afterwards we can design with them and then prototype with them and manufacture. And what about if we are making our own materials, then we can also foresee the design for disassembly, the recycling and biodegradability. So in this topic, there is a very profound research that we started in 2015 about fabricating materials, about biofabrication, how it is called, or biomaterials. And here you can see, for example, a project where we used different fruit peels and food waste to make a series of t-shirts that they are based on algae. So here you can see orange, green tea, apple peel, and coffee t-shirts that they're using this organic waste, but also make objects using the facilities of the Fab Lab, like creating molds in the CNC machine, and then afterwards using recipes where we can make different forms. In this case, on the left, you can see an edible cap. It's using the peels of the potato yucca. So it's cooked also afterwards. So we were thinking, how about creating these edible cups that at the end of the party, you can actually eat them as if they were cookies. And on another project that we made, we created some materials based on mycelium. This is a mushroom, the roots of the mushroom. And in this case, you can see also algae-based leathers, bio-leathers, vegan leathers, but also the colors. The colors that we use, they are also made by us. So I will describe the colors a little bit later, but I can put this small video. So all of this knowledge, since we think that we can have local interventions, but also create a bigger impact in a global level, so we can really talk about the concept of glocalism, of making and understanding our context and our surroundings, understanding the needs and co-creating with the society in a local level, but also being able to have replicability. This is the foundations of research and investigation. So in this case, the Fab Textiles Lab has generated a series of open source booklets or fanzines or zines or publications where everybody can follow these recipes of creating biomaterials. And the new aspect here is that there is a big now movement that is following and contributing also to the knowledge of these recipes. And we are able to see projects that they come out from the lab that they really tackle also the sustainability and the circular design from the material perspective. And designing with the material is also having different values in the way that you approach design. And this is called material-driven design. because when you make the material yourself, you can design also the properties. So you can design the time span you want this material to resist and live. So you can really adapt. If you want a single-use bottle, you can say, okay, this bottle needs to live 1 day and not 500 years. And you can also tackle the thing about geometry and how the elasticity, and probably since we are mostly towards heading to a monomaterial future, then we can think of having the same material using different proportions, where you can have some place that is more elastic, some place that is more translucent, some place that is more rigid. So all the recipes are open. And anyone can follow them. And give me a second. I wanted to talk to you about a project that we did that activates the barrio, the neighborhood of Barcelona, to use organic waste. It's very funny because I never thought that I would work with so long time with garbage. And since 2019, I have been collecting organic food waste, first at domestic scale at my house, and then at district level in the barrio, in the district of Poblenou. And with this, we incubated in FabLab Barcelona 12 designers, where we showed them how to make biomaterials based on organic waste. And we created a collective that is called Remix Collective, Food Waste Biomaterial Makers. And the most important thing of this project is not actually the materials that they were made or the digital fabrication that we used, but it's the impact and the circular ecosystem and community that created in the neighborhood, because we started going out and asking from different stakeholders that have nothing to do with science, that have nothing to do with innovation, that maybe they have a restaurant or a public garden, or they're working in a small association, or they make coffee. And we started asking them to collect and give us their organic waste. And of course they were curious, and they were asking, why do you want waste? And we said, okay, wait, give me like 2 weeks and I will show you what I'm doing. And then we were going back and we were showing to them that we could make different products out of their waste. And they were really astonished with the invention. But the most important is that we created these relationships in a local level. And I think at the end, it's very important to understand that it's not about the machines, but it's about the people. And people are the ones that they're carrying, and they're really having a lot of intention to bring the projects moving forward. And this is also a replicable project, because we were rigorous enough to document also in an open source way all these recipes of working with food waste. And you can see very different and diverse projects that they were designed within the incubation of Remix El Barrio. And now I will let Greg continue with the presentation.
Anastasia, would you share the link to the open source in the chat? Would that be okay?
Yeah, sure.
Thank you.
I will just have to let you know that it is a very big coincidence of this invitation, because actually, since Greg is traveling a lot to Ireland, and myself also will be traveling to Ireland in July to do a biomaterials workshop, and I will let the rest of the presentation to Greg.
Thank you so much, Anastasia, for this amazing presentation of the Fab Lab and your work. So we'll start my screen now. I hope you can see my screen. Jackie, just to check with you. Good. Great. So Anastasia said something that was very interesting earlier. She talked about prosumer. And so the FabLabs and the FabLab network its intention is to shift from a model of production and consumption that's called product in, trash out. This is a slide actually that I took from an initiative that's called Fab City, led by Thomas Diaz. And the FabLab network wants to change that model into another circular model, which is data in, data out. So the idea is that only data is exchanged between FabLabs and manufacturing happens locally. So the reason why the term prosumer was interesting is because even though we have this new model where things are fabricated locally thanks to a FabLab, does it mean that it's necessarily sustainable? It's not so sure, because if we need to tackle the massive issues that the world is facing, like with CO2 emissions, climate change, deforestation, pollution, are we really going to solve those issues only by manufacturing locally? Because it turns out that mass production is actually more efficient than just doing small series in a local fab lab. So the problem is not the way we manufacture things. The problem is consumption. This is the big issue to tackle, how we consume things. We just saw, thanks to Anastasia talk, that with the Fab Labs, we can make almost anything, but doesn't mean that we need to make everything. It's not because we just have the tools. It's not because we empower people to use those tools to make almost anything that they should make everything. So how do we set limits for ourselves? How do we make sure that we're not going to overuse the planet by doing local manufacturing? And there is great wisdom in setting limits there. So how do we set up the limits? Because we can see that between the awareness and the philosophy, we all agree that we need collectively to set some boundaries, to set some limits. So we all agree on that. We are aware, but between the behaviors and the awareness, there is a huge gap. And I can tell you a little story where I really witnessed that. So I was involved in the building of a self-sufficient house in France. And I was working with the clients before, during, and after the build. And after they moved in their house, they called me and they said, Greg, we have a problem. We don't have electricity anymore. So I thought there was an issue with the system. So I went there and I checked the consumption curves, and I saw that there was no problem with the system. It was actually that they drained their batteries. They just overconsumed compared to what we had designed together. So those people, they are advocates of self-sufficiency and ecology. They actually are journalists and they write in magazines about it. And they moved in their house and they found out that despite the fact that they are strongly advocating for this, their behavior was completely off. And it struck me when I witnessed that, because I realized that the tangible limits that we actually face today that we face daily they act as a personal coach. They really define how what we can consume and not overconsume. So self-sufficiency is actually a handrail to sustainability. By having daily limits where we live, we definitely bridge the gap that there is between the awareness and our values and our behaviors. So this building that you saw before, this one, it's actually called an Earthship. So there are buildings that are already designed to be completely self-sufficient. The way they work is that they can you see my mouse on the screen? Yeah. So we have a greenhouse on the south here, which heats up the air, and there is natural ventilation. We let the hot air escape here, so that it creates a draft, and we have temperature stability year round. this building also, you can have here a view of an actual greenhouse, and we produce food inside the house. This building collects water and is used. So the water is stored at the back here, and then we use the water one time. It becomes gray water. This gray water is filtrated into the greenhouse through an evapotranspiration bed, and then it's used again to flush the toilet, and then it's used a fourth time to grow stuff outside into an outside septic system. And in order to function, this building has a lot of low-tech technologies, such as filtration system, extremely low-tech here. This is a salad bowl that's actually used here. And we have filters and pumps to bring the water up to drinking quality. We also have different cells, and they're called evapotranspiration beds, so that the gray water can be cleaned and reused afterwards for the toilet, for flushing the toilet. Yeah, pumps and filters, and all of those low-tech systems, it would be amazing if we could actually produce and maintain them thanks to a local fab lab, because whenever they fail, we need to not only change the whole system, even though it's just a little part that broke, and sometimes this whole system is coming from far away. So having a local manufacturing place just to maintain the systems would already be much more sustainable than the way those objects are produced today. Another example is the electrical system with inverters and solar controllers. All of those can be maintained and even produced in a Fab Labs, because we can produce electronics in a Fab Labs. Here are some batteries. So of course, I know that there are things that we still cannot make in a Fab Lab, but as Anastasia demonstrated, it's also a global network of innovators. So citizen science is really making a move towards exploring new ways of making those batteries, even PV panels, photovoltaic panels, locally, thanks to your local Fab Lab. You can learn those things, those systems and how those houses are built. There is an academy for that. It's called the Earthship Academy. We're going to run one in France next year. This is actually a first one that we ran in 2017. So there are a professional team, and there are 40 to 60 volunteers and students that are receiving teaching. There are theoretical classes and on-site classes. This is another example in Argentina. It really is a global academy. And we're going to teach some of those things. So this is not directly linked to Earthship, but I'm actually involved in Ireland to teach and build with a newborn company there that's called Common Knowledge, and this is the website. And we ran some courses already, and we're gonna run some courses in the near future. So you can check it out. So the idea of the Fab Lab, the self-sufficient Fab Lab, as known as Fabship, is embedding all of those digital tools plus manual tools into one of those self-sufficient building. And again, the idea is, as I was explaining before with this couple that discovered that their behavior was not really matching their philosophy, it's the same idea with a production unit here. So we're going to start this project this summer, pretty much. The building of the Fabship is going to happen next summer, 2023, in France, in the south center of France. So we're going to run one of these Earthship academies that I was talking about earlier in a place called Lozère. And it's a place where we found all of the urban regulations so that we could build a self-sufficient building. So back to the concept, the self-sufficient manufacturing allows us to enter a virtuous cycle, going through 3 main phases. Phase where we build up autonomy. Then, thanks to this autonomy, we can collaborate more. And then, thanks to this collaboration, we can decentralize maintenance and making of systems that we actually need to be more autonomous. So, hence the cycle. So, if we zoom in, we start with self-sufficient system, for example, a pump, and then this pump can then make locally, we become self-sufficient with water, and then we can raise our awareness when it comes to water consumption. And then with water or with electricity and other things, we can distinguish between what we really need and what is off-grid. So again, those limits, they help us prioritize what we're going to make, what we're going to produce in this self-sufficient production unit. And then when the basic needs are easily and locally satisfied, stress basically goes down and the feeling of safety goes up. So we believe that it's going to free some time and it's going to allow people to dedicate some of their time towards collaboration. Basically, as we see today, people spending their time to participate into the creation of open source software and open source hardware as well. So you remember Anastasia showed you a slide with all of those initiatives that are already open source. These represent people that are actually giving their time to produce the best software possible so that everybody can use them to do things. So thanks to the sharing and of the way things are made, thanks to the open source, we can distribute the design of systems, and we can then have a massive and worldwide collaboration that leads quickly to very efficient designs and sustainable ones as well. And these designs, they are meant to also adapt to your local context. For example, this is the open source Beehive project. And those wood joineries that you see there, they are meant to be easily adaptable to the thickness of the plywood board that you're gonna use. So in a single click, with the source of the 3D design of that object, with a single click, you can change the shape so that it matches whatever material you have locally. Another example also is how you can branch out of something that's already made. Here we're talking about an open source Beehive, and this design, because it's open source, was taken by another group of people and modified into an aquaponic system. So we can see the value of having adaptable designs. Same thing goes with electronics. And also a very famous project is Precious Plastic project, where those machines are open source. You can make them at home, and then you can recycle the plastics that you produce and turn them into an object. This is another example of a cooperative in France of open source designs for farming machines. All of the machines that you need for tracting and sorting seeds, they're already open source and ready to be made locally. So we're back to this cycle, and thanks to this ability to adapt designs to whatever material you have locally, we can not only make self-sufficient systems and we close the loop, but we can also innovate to go further, for example, to explore areas of research that is not necessarily covered by academia today, because it's judged to be too low-tech or not interested in terms of profit. For example, a team of people across the world could collaborate into making a pump, a simple pump that can be
made in a local fab lab, and you can already make that because those pumps are made from silicon, so that the membrane is made of silicon, and this can be cast locally. So then you close the loop, you have a self-sufficient system, which frees up a little bit more independency, and then you can engage more into collaborating into those systems, etc., etc. And thank you for your attention.
Thank you both very much. Has anyone any questions or anything they want to say? Freddy, I think you're in silent. Yeah.
I'm working on similar topics right now. I'm super interested in the ink, and I would like to use it for drawing with those ink pencils.
I think it's a great example of how something as simple as an ink pencil should be made locally.
Yeah, maybe if you find a link to post in the messages for where to get started with the bio ink. Like, I guess I could search in the Bio Academy or in Fabricademy.
But firstly, I made I made recently a post on the fabtextiles.org where I created this ink from pomegranate peels that is a very old technique, the very technique that they use to dye carpets black. And it is all documented there. There are two recipes. One is for making ink, and the other is for making paste.
Okay, great. Thanks a lot.
Yeah. Well, I hope that I thought that you wanted to ask us about the what are the current situation and steps on building an off-grid Fab Lab, which is the actual project, but I can also say that we are actually trying to find some finance for both the FabLab equipment, but also for the build, for the shell of this building. And the good thing is that basically in the place that Greg went and he presented the project, they are very, very happy with creating an eco community. They are very supportive to the project, and they let us be able to build 10,000 square meters out of which there are the common houses and also the private houses. So in this case, what we are thinking is that we want to have people not slowly, but people that they can come slowly, that they want to contribute and be there, that they want to build their house, and slowly they start building their houses, more or less small footprint of 80 square meters as a base for the house. And then we will have 3 common buildings. One of these will be the Fab Lab, and the other will be more workshop, dirty workshop, and the other will be more like the communal kitchen and eating and having yoga and these places. So now we're currently working on the inventory, and then Greg will work on the consumption of the machines, so that then he can dimension the solar panel that they are needed for making a fully good Fab Lab.
Yeah. Yeah, you could have a chat with the Algarve Fab Farm. Lucio is running completely on solar, a little Fab Lab and his house and everything. I'm sure he knows exactly how much he's consuming.
Do you have contact details for that? Because I was actually speaking to a lady today who's vertical farming, and she has no solar energy at all. So her biggest output is actually the heating costs and the electricity costs of her vertical farm. We were talking about project would you be able to direct me in the chat maybe?
Yeah, like I studied this. I could like this is kind of my job, and
okay, I will put my email in.
Also, Ferdy, something to say on top of what Anastasia just said is that we're going to be opening some residencies pretty soon after the Fab Lab is made. Maker residencies, so that people can develop their own project there and be able to say this was designed and made and prototyped into an off-grid Fab Lab.
Awesome.
Actually, the lab that is more developed in this aspect is the Farm Lab. It is one of my partners that she makes, Martin Goodman. He has a lab in a farm, and they are currently, just finished putting the solar panels on the whole roof. Oh, wow. So now they will connect. It is an amazing project. We are working on them on a research on revalorization of wool, lana, and they have there all the machinery and everything. It's very amazing place.
Super awesome.
Greg, I have a question. Could we I don't know, design a specific energy saving workshop so we could make it here in Mexico with the things that you made on this Earthship project or so? Is it possible?
Yeah, sorry, I don't have my video because I think that's the thing that's freezing my computer, but I heard you. And yes, in Mexico, you can totally, you can totally design such one of those buildings. It's you definitely have enough sun exposure, but then you need first to identify what is the machines and what is the rhythm of consumption that you want to use in your Fab Lab so that you can design.
Yeah, but not only for a Fab Lab, but also for houses and all this system to cool air and for houses.
For houses, you can. This already exists. I'm sure there is an Earthship in Mexico already. Actually, I believe so.
I would search for it. Okay.
Yeah, search for it because I think we've built in Mexico. What was the year? I don't remember the year exactly, but it works definitely. So it works for the house. That's already proven. Now we're gonna go a step further and see if it works for a production unit, basically. I mean, it will work, but the interesting thing is to see how much frustration we're gonna face with the slowdown that we need to make with the production of things, because we're just gonna run the machines on the natural cycles. So some days, we will have to tell ourselves it's been raining for like 2 weeks, maybe we cannot produce now. So yeah, it will work for a house for sure. And now the step is to see how well it works with the production unit.
Actually, if you're interested, we can talk with Trini from FabLab Maya. She's about to build their own Fab Lab. Actually, she's renting now, and she's going to build a new facility for her Fab Lab, and she might be very interested because it's in the Cancun area. It's okay. Very sunny. It's very, very sunny.
Yeah, I've been there actually a long time ago. So it is very, very sunny. Have a link maybe.
Yeah, I have.
You have the link.
Of course, Anastasia, you know Trini.
Yes, and also Trini, this year she was making her own Tintoria garden. So she was planting plants that they make colors. And then she can, they also have this in the Farm Lab. She's growing the plants and then extracting them to be able to make the dyes afterwards. And on, by the way, on Monday, we have this open workshop open to everyone, which is coloring wool Wool Mondays, it's called, and then we will show how to make, how to dye and make colors from roots, from barks, from food waste, and from flower printing techniques. On it is published Wool Mondays from She Makes, and it is online and hybrids, like online and here in the different labs. And then next Monday on the 23rd, because it's a Wool Mondays, many sessions, we have open source tools for making a little wool factory, domestic scale, setting up the whole chain for spinning, for carding, for weaving, knitting. So mainly I'm working on a research of collecting all the open source projects that they compose all together this little wool factory.
That sounds amazing.
Okay, so I think that thank you so much for listening to us, and very happy to see Aristarco and Ferdi. Very nice that we had the possibility to talk in this intimate setup. And thank you, Jackie, for organizing.
Yeah, thank you.
Thanks for agreeing to speak. I really enjoyed it, and I have a book full of notes. So thank you both very much. Our Fab Lab is about 3 to 4 months off opening. If the builders don't create any more delays with global issues with supply. But Creative Spark hope to have an enterprise Fab Lab open in September, October to start delivering courses and Fab Lab experiences. So yeah, it's an exciting time for us.
Well, thank you guys. Thank you very much. Hopefully we can see each other in October in Bali.
Mm-hmm. Very great.
Thank you, guys. Difficult.
Thank you very much. Thanks, everybody.
Thank you. Bye-bye.
Thank you. Bye.
Bye.